322. So those who took 322 will know more or less on how we will do things. Personally, I believe that learning is a process, and what I will try to do through these classes is not just to teach you the content, but to do two things: to introduce you to new concepts, to talk about the importance of those concepts and how we use them. And my hope is to give you enough reasons to go back and learn more about it. There is no, of course, there is no way that in 14 weeks you will be able to become experts in microwave components and systems. I mean, it takes a lifetime to really become an expert in this. And the learning is continuous. And a lot of the learning you will do yourselves. So I will try to help you learn, be more aware of why this area is important. I hope I will try to make you like it, because if you like this area, then you're going to find the time yourselves to learn more and get more involved, and hopefully to learn more along the way. So that is where I'm coming from. So learning is my number one priority for this class as an instructor. The second priority is to give an assessment of your level of learning or participation or interest in this class. So grades come second. And a grade, I'm not going to use it as a penalty or a recognition for anybody. The grade is just a measure of what kind of activity you showed in this class, how much you got interested, and how much time you spent, how you thought about things, and how you were able to work together. So the grades are not competitive. In fact, I will not even try to compare you against each other, because each one of you has a different style, and all of us contribute to a topic in different ways. There's not only one way to contribute, but the outcomes may be very good. And so in that regard, I don't necessarily believe in giving 30% A's or 30% B's or 30% the rest, because that implies that some will get higher grades and some will get lower grades. I mean, you know, if I fix my average, some will be above and some will be below. And I don't necessarily like that competitive thing, especially competition in learning does not have the same meaning as we compete for other things in life. So my approach is the following. Ideally, optimally, I would like everybody to do extremely well, which means that I could give an A to everybody. And practically, as I have said many times, in this level of my career, I don't have a problem doing that. And obviously, that does not happen exactly this way. But as I said, I don't have a fixed interest in grading that way. And that's why the system that I'm using for grading is the point system. So we'll go into this. So if everybody gets very high points, I mean, practically everybody can get an A. If many students get very low points, then, you know, they will know ahead of time of what is happening. So let's try now to help you navigate through. And then if you have any questions in the process, you can type or you can just speak out, as long as it stays quiet. I mean, for everybody else to hear. All right, so the course objectives. If you go through this, you will see what this class wants to accomplish. And I wanted to say that the blue and the purple are the areas without much on radars, but you know, radar is a particular system that has a particular goal, but the subsystems within a radar are not very different in principle with many of the subsystems within wireless communication systems. Now, antennas, we're going to use them as an element. There is a lot of material you can learn on antennas, and this is not a class for antennas, so we are going to cover very little of it. We're going to talk about that. But in any case, we're going to use them as an element within a wireless communication system. So practically, the material that we will cover, while in principle will have a lot of applications, the way we are going to look into it will be through my lens, which is, in fact, has been colored by my own experiences, and all of the work that I have done so far is in microelectronics. So you can get a sense of what my focus and where my experience is. So number 2, I wanted to remind you, nobody knows everything. So even I am the instructor for the class, it may be, especially as the courses become more and more involved, that you may have questions, and I hope you have many questions, or a number of them, for which I may not necessarily have an easy answer. And in that case, I will tell you, if you ask me something and I'm not very familiar with the topic, then I will tell you that I do not know it, or I do not know enough of it, but I will learn and I will come back to answer your questions. So that is another thing. As a matter of fact, one of the principles of learning is to be aware of how little you know. And considering how much knowledge we have been producing over the so many years in the area specifically of microelectronics, I can tell you it's definitely true that there are specific things that either I have heard about, I know little about, or maybe some other things that I know a lot about. So we hopefully will explore the whole spectrum of my experiences, and I will only try to help you learn, even for things that I may not necessarily be an expert on those. So here you're gonna learn more about the class. Then why we learn in teams. Let me see. There. There is no engineering work that is done individually. The only time when, even not anymore, I mean, yes, when I was a graduate student, I was supposed to do things individually, but most of the time, I mean, if 99, if not 100% of the time right now, engineering projects are done in teams. And yes, you need to know enough so you can contribute as an individual in a team, but the work of the team is really what characterizes your contribution. And I know that I have to give individual grades. Practically, I have to assess each one's learning, but the team work is going to be extremely important. So you see that I give every opportunity we take, we are going to work as a team. And in some cases, you will have to submit individual work, even if you are allowed to speak with your other colleagues in your team. I have assigned all of you in teams of 4, and it was done randomly, just because I don't know all of you, and there is no point for me in trying to create teams with people that I don't necessarily know well. So in case you have, it's going to take us about 2 weeks to finalize the teams, because some other students may come to the class, some students may leave the class, and it takes 2 weeks to really stabilize the population, the student population in the class. So we're going to go through some changes, And that gives you time as well to, if you like to team with some of your colleagues, you can do that, but you have to ask me to do it so I can keep track of the changes. Early on, when the teams have not met, it's easy for me to make changes, but as we get into learning the material and then you're going to work with your team, if you still want to leave the team for some reason, or you want to bring somebody in, or you want to go to another team, you may, of course, you have to tell me, but at the same time, you will have to tell the other members of your team. It's not a good idea for you to disappear one day from your team. That's not a good practice. So you will tell them, of course, it's your decision. Nobody's going to stop you from doing it, but you have to inform them. And then you have to come to me and I will make the change as possible. Of course, I will try to accommodate you as much as possible. So that is about the teams. And you should be able to find your team and team colleagues because I have already done that. And so you're going to have an opportunity then, in case you want to change, to email me and tell me and explain to me. I would like, not just because for some reason, I would like to know why it's important that you join another team. So I would like to stop here and see if you have any questions before I continue. I don't see anyone writing. So let me go to the course schedule. I tried the best I could to project what we are going to do in this class. And I started, just to attract your attention, I'm going to use a lot of graphics. I like them myself. They have visual information or attracts attention. And so here it's easy to split. It's a very long document, so you will be able to see weeks 1, 2, and so forth. What I have tried to do in each week is to see what activities are anticipated. All of these are anticipated, which means that as we go through the class and some very changes will happen one way or another, either I will have to slow down in some places, so we're not going to be able to cover as much I have anticipated, or I may skip some things, which means that some things may not happen. So every week as we go down to the final week, which is down all the way to 15, and then I show you the points you're going to get from all of these activities. I will, every week, I will update it. So for the weeks that have been passed, the information is going to be accurate. But for the weeks that are ahead of us, the information is only an estimate. So just so you know. There is a question about what are the team projects, and that's what it gets me to the next. So this class is different from 322. 322 is a prerequisite, which means, and I will come to the material that you need to know. But this class is focusing on microwave components and systems. So what I decided to do is to teach the class in a different way. Usually the traditional old style teaching of a class is to start with the individual components and build it up and then eventually go to the system. And if you have time, you do the system. Now, that's the way for those who speak another language. And for me, English is a second language. I was born in Greece. So the language that they were trying to teach me in the beginning and all of the I started learning English when I was in second grade. My father was in a naval base, NATO naval base, and there were, the kids of all of the officers were going to the same school, and we had kids from the Americans and the Greeks, and then all of the kids were going to the same school. So in the morning we had Greek, everything in Greek. In the afternoon we had everything in English. That's where I started learning. And that was really excellent because we did not start with the alphabet. Say, when I started learning English, they did not try to teach me the alphabet first, and then words, and then more words, and then the grammar, and then all of these things. They did not build it bottom up, but they started talking to us in English, which is different, and that's how people also teach other languages nowadays. So if you're going to learn, say, Italian or Greek, they're not going to start with the Greek alphabet, and then you have to memorize the whole thing, and then you have to start with words, and you have to memorize all the words. They will try to start you with conversations. And yes, there are a lot of things you don't understand. You cannot speak when somebody speaks to you in Greek, and you have no idea what they're talking to you. But after some time, especially if you live in that space, you start learning, you start understanding what they're trying to tell you, and then you associate words with things and actions. So the equivalent to that for this class will be the following. We're not going to wait until the end of the class to start learning about systems. We'll do it the other way around. I'm going to introduce the systems very early, and I will show you a little bit today on how we're going to do that. And then each of your team, we're going to have a system in mind. Each of your team can select a particular receiver system from the ones that I will present. And then every week, I'm going to do two things. One is going to be homework. We are going to start, therefore, building, as we have systems in mind. We will start explaining why every part of the system is important and how to design it. And so as we are learning those things, you are going to also design the components of your systems along the way, which means that every week I'm going to give you homework on the material, but also I'm going to give you questions and or specific tasks, which will be based on the material of the week, but which will help you to build up your system. And so hopefully along the way, you're going to start building up your system. And then halfway, when we have the midterm, you're going to give me like a midterm report of your project to tell me where you are. And then at the end, you're going to give me a final report of your project. Now, I don't want 25 pages or anything, as you can imagine. What I would like is I will give you discussions. Somebody's asking me a question, my guess is.
I have a question. So I see on the page right now that you have a Top Hat as a submission for Top Hat. Is that just a scanning tool, or are we
I'm going to get into
things
this
directly into Top Hat for?
Yes, it goes directly into Top Hat, and I will show you how we are going to use that. Okay,
so we directly submit in there, so we do need a membership subscription for it, even if we use other tools.
The only other tool, the Top Hat, is what we're going to use in class. And the only other tool which is free is like any application that allows you to scan a document, so you can upload it as a PDF.
So do we upload our homeworks onto eCampus or into Top Hat?
No, Top Hat is only for in-class questions and quizzes.
Okay, so we still need that for those like in-class questions?
You will see how it is. So one at a time. I know what you're asking.
Thank you.
But when it comes to homework, as you can see here, homework 1, homework 2, all right? So where I have homework 1 and 2 here, those will be uploaded to campus, downloaded to get the questions or the homework, upload the solutions or the responses. Exercises 2, 3, and quiz will take place in class or immediately after. I may give you a couple of hours to do them or more, depending on but your solutions will be uploaded on Top Hat, and you're going to see exactly the grade real time. the points rather, there's no grade, the points you're going to get real time. And those will, and this is, the exercises will be exactly in the material we covered in the class, in the lecture. The quiz is going to be on the material we covered the last 2 lectures, rather this much. It's the only reason I'm doing those is so you keep thinking about the material, because the way our brain works is that if you come to lecture, you understand everything, and then you go and start doing something else. And then you only come to the next lecture, by then you'll probably forget a lot of the material we cover in class because you did not retrieve it. But when you have to do something as a small task right after, and you force your brain to think, then the probability of holding this information, it's much better. So that's why I'm doing this. And I will show you how. So homework, midterms, finals, all in eCampus. The rest, you don't have to upload anything to TopHat. It's real time, you do it on the screen. All right, so somebody asked me about the syllabus. Here is the syllabus. This whole thing is the syllabus, as you can see. It says everything we're gonna cover here for lectures, and then there are other things in the syllabus which are important, so you will have to see them here. Is the course grading. This explains how you're gonna accumulate points. That shows you how I'm going to grade the class. So if everybody gets above 6,000, everybody's gonna get an A. I'm not gonna do this scaling thing, or whatever they call it. The curving, I'm not gonna do that. I'm not gonna decide that the average is gonna be B. I'm not gonna do this. You're gonna get now, it is true that if I give you very hard problems and nobody reached like a 7,000 and nobody reached 6,000, it's not gonna happen, but I'm just telling you, then I will always start with the highest number of points with an A. All right, so I'm not gonna do the absolute grading. It's somewhere between a scaled grading without a curve, and an absolute is not exactly though either one. Okay, so the highest number of points in the class is equivalent to 7,400. All right, 7,460. According to my expectations, speculations, and rather, this is the highest, will go close to that, the highest for the class. But if I give difficult things and people give me a 6,000 maximum points, then we are gonna start at 6,000 and then go down, okay? So I need to explain that to you. So this is the grading. Then accommodations. I suggest that you read this very carefully. Make up policies. How do you solve a conflict in your team? Make up policies, all right? And then these are for accommodations, but then we go to university policies for a lot of other things. And I put it separately because the university, of course, due to COVID-19 and the way we do things, has expanded the policies. So we have attendance policy, the rules, so I remind you, make up work policy, and everything that I do, it will follow those rules, but it's important for you to have access to them. Academic integrity statement and policy, remind you the Americans with Disability Act's policy, Title IX policy, statement that the university about mental health and wellness, COVID-19, the campus safety measures. If you are going around campus, you have to follow exactly, you have to, first of all, to keep yourselves healthy, and then keep everybody else healthy. We are a very large community on our campus, and our responsibility to keep our community healthy is extremely important. So please take some time to read those policies. They are all here. I tried, instead of including a huge document, to place them, to divide them in sections so you can see it. Textbook and reference books. Our textbook is Microwave Engineering by Pozar. I would rent it. I would not buy it unless you have a copy of it for some reason. And then I use 2 reference books. You would not have to buy them, but I will borrow some material out of these books. If I borrow the material, I will tell you out of which book is coming. It's not going to be full chapters. I mean, maybe some pictures here and there. But I just want to tell you that these are the 2 books that I have used for some things. The Microwave Engineering book by Pozar is what you really need. That textbook and my notes. If you follow my notes, then you will have everything you need. Okay, now Zoom meetings. I'm sure you all have found them. These are all of the Zoom meetings. We'll have the lecture that starts at 1:35 to 2:25. And then I will have office hours from 3 to 5. Every Monday, Wednesday, and Friday. Why office hours are important? There is no way I can see you while I'm teaching this class. And since I cannot see you, it is very important that I see you during office hours. And then I would like you to come in teams with your team. If there is a personal reason that you need to talk to me individually, then please send me a note and I will make sure we'll set a time and we're gonna meet. Usually for my office hours is first come, first serve, but since I would like to meet with the teams, I need to find a way to have a calendar for this so you can sign up. I have not done that yet, so I will try to find if there is an easy way. If you know of a calendar that you can sign up yourself, that I can use it for my office hours, let me know. If there is an application that I can use, I did not have time to look into it. That's gonna make it easier for you so you don't have to wait. Now, waiting is not like waiting physically, so you can always connect, and when I call you in, then you can. But again, it will be nice to know that from these 15 minutes is your slot to speak with me. So office hours are extremely important. You can ask me about your project, you can ask me about homework, all kinds of different things. But it will be nice for you to come in teams because it's better to have 16 teams to see and hopefully each team, each one every week, as opposed to 64 students that I don't know how we're gonna manage it, but I still need to get to know you. So with this one, we go back to now office hour. Let's go to Top Hat. Okay, I sent an email today to all of you on how to connect with Top Hat, and I will show you now what I was gonna do. And if you have any access to Top Hat, then you will see how we are gonna do things. So for example, in this particular case, I will use it as an example. This is week 1, and here, you don't see, this is what I see. I have 1 exercise. Now, I may choose in this exercise, the question is the following, and it's a question based on, it's a review topic, something that you cover in 322. So the question says the following. First of all, this question takes 30 points, and then they go automatically under your name in Top Hat. You will have access to your points. You will know what is wrong, when you got right. And I will also have an explanation in case you got it wrong. So the software allows me to do this. This is the question. It says, when can we use a single word quarter wave transformer to match a load to a transmission line? And there are 4 different answers. When the load is an inductor, L. When the load is an LC circuit. When the load is an RC circuit, or when the load is a resistor. So I give it to you, I assign it, and say assign then you will be able to go and check an answer. Okay, see, I saw someone who I see. Now, this is not, you're not gonna see that, but I see who is checking the right answer. And in real time, as others are entering the answers, which is the correct one, if you remember, the quarter wave transformer can only work successfully if you have a resistive load. If it's reactive, as you have seen, and then we will remember throughout this class, you will need to use a stub. You need to use a matching stub in addition to a transformer if you want, or depending, of course, on the circumstances, one stub alone may do it for you. So, and then I see 15 here, see 18, I see how it goes. So far, nobody got it wrong. Of course, I explained. But as people entered, now in this one, I have to tell you, since we did it this way, I'm not going to give grades for this one, or I will give everybody a correct grade, either one. But I'm not going to give grades. We're just using it as a test. So if I give grades, everybody's going to get a maximum, or everybody's going to get a 0 for this one. So we all start at the same level. That is Top Hat. Now, what I see from Top Hat, let me show you what I see. I go to students, and you see the students here. And then how many students got enrolled? Enough, many. Then if I want to see how a student has done, even if they change it, status, active, let me see. Where do I see students? Probably gradebook. That's where I see it. So I can go to gradebook, and I can see how many students have responded, and you can see immediately the grade you got. Always half of the grade is for participation, and the other half is for accuracy. So if you just participate, you get the wrong answer, you get 15. If you get the correct answer, you get 30. So I can see it, and then I can see it by week, you see? And I see all the students, and then I get the total numbers and so forth here. So that's what I see. So I need to go back to this one. Any questions on Top Hat? You can speak out if you want.
I don't have a question about Top Hat, but I do have a question about the schedule on the syllabus.
Yes.
So on Friday, September 25th,
yes,
you have Top Hat quiz number 6. The September 25th is also Ring Day. So I was going to ask.
Okay. What is Ring? You know, I went by the university academic schedule and what was available to me. And I did not see, I believe, any, Labor Day is a working day, I believe, because they did not have a for us. And so Rain Day is, what do you mean by that?
Not Rain Day, Ring Day, the day that the university, the event where people go get their rings. I was going to ask if there was for those of us that were getting our rings on that day, I was going to ask if there were any alternatives for us to be able to take that.
Sure, yeah. You know, what happens is I have the makeup, and then when the makeup is very interesting on how I do it. So it allows people to pick up different types of points. So it is one set of many questions, and then depending on how many points you have missed for a good reason, then you need to do so many questions. So you're going to be able to, you will be able to then make up for it. Now, if there is a special case, I may have to do something for one person, depending. But usually I have found that through the makeup assignments that I give, two, I will give one after the midterm, just in case somebody has even missed a midterm, they can even use the makeup assignment to do that, or before the final. For the final, if somebody misses a final, then I think it gets an incomplete, and then the person has to take the final and get a final grade. But the makeup assignments will take care of this. I'm sure there will be other things, you know. I mean, we are all human beings, and we all have things that happen to our lives, and it is important to acknowledge it and then give opportunities to students to make it up. Any other questions? Okay, now let me go.
Can you leave the top hat question open for a short while?
Yes, I will leave it open if you want. Usually the top hat, sometimes if we give it in class, I may tell you, you have 5 minutes for it, and then I will turn it off. Or I can give it to you at the end of the class and you say, you have 2 hours, you know, to do this, and I will then turn it off. Or I can tell you have 6 hours, you know, I mean, depends. Not that it's gonna be, I mean, this answer, either you know it or you don't. As you know, it's part of the, but sometimes students, if it's a little more conceptually complex, the students will have an opportunity to come to my office hours and ask more questions. So sometimes I leave it open. Today I will leave it open until the end of this lecture, and then I will close it. So that's about it. And then any other questions about Top Hat? Okay. Now I'm going back. Let me see where I'm going. Here. Okay, now let's go to look at the weekly modules. There you're gonna see, now what I plan to do as I do today is that I'm starting with the same thing as I have. Exercise 1, Wednesday today, 30 points. And then I have 3, you see those uploaded files. These ones is what I'm going to then show you today, and then we'll talk. And then usually what I will do, starting like Friday, I'm going to lecture out of these files, and then I'm going to upload the files, and sometimes I will have them ahead of time. Some other times, if I do things on the screen, I will also upload another file after the lecture, and then also the recording from the class, like now the class is recorded. I will put it on a YouTube channel that I have, and I will connect that, so you will always have access to the recording. And I will add it also here. So you will always find, and my advice, if you want to see things to review, go through this website. Do not go through the content collection. I will try there also to put it by week. But here you will also have it, I don't know. I mean, I like to use this kind of website, look at the material. But you will always, of course, they are in the content collection area as well. And I will try to put them in folders by week. So let's go to abbreviations here. What I wanted to do is that as we cover material, you will see that especially in the area of, and I see some typos here, but that's all right. In the area of microwave components and systems, in electronics in general, there are a lot of abbreviations. So people do not say CMOS. You know, a lot of you know what CMOS is, complementary metal oxide semiconductor. You see CMOS. complementary metal oxide semiconductor. We're not going to just say complementary metal oxide semiconductor all the time. We're going to say CMOS. The other thing is FDMA, frequency division multiple access. This is a method that is used for the modulation of signals. The same. FET, even if it is not supposed to say filed, it's supposed to say field, like the electric field, field effect transistor, that is. FM, frequency modulation. AM, amplitude modulation. GSM, global system for mobile communications, all of these. Let me see. OFDM, which is the orthogonal frequency division multiplex, which is something that they're using in 5G today for wireless systems. We're going to use that, so I'd like you to have this available. You're going to get very familiar with some of this, not with everything, but in the beginning you will probably need it. So then let's go to talk about the class. This is introduction to class. And here I just wrote what the things we talked about. All right. Also, I put a picture here. And why I like the picture is because in electronics, we use different ways to represent circuits. And here you have in B, a schematic representation. See, we have symbolic rather representation. We have symbols or schematics that represent different components. And then you have this schematic representation that is utilized for design most of the time. But in reality, when you look at A, you see how it looks. Of course, they are elevated in free space, so you can see how the various layers have been developed in this case. This is a multi-finger transistor. But then in E, you see how it looks vertically. If you cut, say, the wafer, like vertically, then what kind of different layers you're gonna see. So I just put a picture here. We're not gonna get this much. We're gonna have some discussion because by itself, the fabrication of like a CMOS transistor or of a FinFET or like another type of a transistor, it's a whole different area of electronics. So we're gonna say a few things, but we're not gonna try to get too much involved. If you get a job in a company as a process engineer, then you will have to learn all of these things very well. Otherwise, if you just become a designer, you will have to be aware of this, but you will need to be very familiar with the schematics. So in any case, I put that figure there so you can see it. And then the rest of the here from 1 to 6, excuse me, I need to go back. Oh, sorry, what did I do? There. So the rest is what we covered today. So now let me go to the last one. And here, I will go to Introduction to Communication Systems. Okay, so this is really the first discussion about the types of communication systems we're gonna do. We call the microwave for this class, but in reality will be, of course, communication systems. Every communication system has two major subsystems. A transmitter that we indicate by T, and a receiver that we indicate by R. And there are two different types of communication systems. One where the transmitter and the receiver are connected by a fiber optic. And the second where the transmitter and the receiver are connected by free space. The first one is called a fiber optic communication system. And the second is called a wireless communication system. And of course, with 5G and everything, the applications of the wireless communication systems are so broad that we are going to spend our time talking about wireless communication systems. So we're not going to do the fiber optic thing. Even if now in very high frequencies, when you have subsystems that they are on the same somehow, they're not very far away, but they are in some proximity, and you want to communicate information in between them, you can use photonic circuits. So there is in very high frequencies, and these are terahertz frequencies, like above 100 gigahertz. And just to remind you, 1 gigahertz is 10 to the 9 hertz. So 1 gigahertz is 10 to the 9 hertz. Microwaves are somewhere between 1 and 100, even if going towards 100, sometimes we call them millimeter waves. Above 100, sometimes we call it sub-millimeter waves, like the wavelength, it's becoming a fraction of a millimeter, or terahertz. And terahertz, 1 terahertz is 1 million gigahertz. So a terahertz, if 1 gigahertz is 10 to the 9, a terahertz is 10 to the 12. All right, so, and above, way above terahertz are optical. So in the area between 100 and 300 gigahertz is a very hot area now for the future of communications. So in any case, I'm saying all of these things because obviously we're going to focus on wireless, and we are going to focus on things that either you're going to see in 5G, or you're going to see above or beyond 5G, like in terahertz applications. Okay, now, there are a lot of, as you remember what I said, that we are going to start talking about systems without necessarily knowing how to make them. But I wanted to just then discuss how many different receiver architectures we have. We have many, but primarily I will split them into 3 categories. And we are almost ready to get done, but I will just finish with this. And I will explain starting Friday. So we have a tuned homodyne receiver. It's a tuned radio frequency receiver, either analog, tuned in an analog way, or tuned digitally. We'll explain what it is. We have a heterodyne receiver. This is the most robust wireless system that everybody's using. We use heterodyne receivers, not only for wireless communication systems, but for radars and all kinds of other things. And they have a single step down conversion receiver, and we'll explain why this is important, but what are the problems, and why then do we go to image reject radio receiver, and what kind of problems has that solved. And then now we go to a little more new architectures, which is the direct conversion receiver. And then there is a direct conversion analog, and then a direct IQ radio receiver. We'll talk about those and why it was very difficult doing these direct conversion receivers a few years back. Say when I was an assistant professor about 30 years ago, it was practically difficult to do a direct conversion. But now with everything that is happening and all of the new technologies, direct conversion is what people like because obviously it's simpler. So in any case, I will then cover that, start covering those on Friday. And it's somewhere between those 3 categories that you may choose. Of course, all of the designs will be paper designs, you can imagine, all right? Everything we'll do in this class for the project will be paper exercise kind of thing. But we are going, it's like we are solving a project like in the homework format, where we take smaller pieces, we know the big idea, and then we will take smaller pieces and build it up. It's like we built a house. We know what kind of house we want to build. We're going to talk about the house, why we selected it, and then we're going to start selecting the material that we need to build it. And all of this, of course, on paper, but hopefully by then you will know some things about microwave systems and components. And with that, I would like to finish here. Do you have any last questions for me?
Yes, are these, I don't know if you already said this, but are the notes, are they just going to be available during the Zoom lecture itself?
Most of the time, yes. But sometimes I will write notes while I'm talking. Those are already available on eCampus. Many times I will have them prepared ahead of time. But as we move along, I will also do things on the screen. And those then I will turn into a PDF file and upload it after the class. Any other questions? Okay, you will also have the recording. Do we have to buy the textbook? I said, no, you just rent it if you want. You don't have to buy it. Buying it is very expensive nowadays. Unless you want to buy it, I bought it on ebook. I put it there. It's much less expensive, but you don't necessarily have to buy it. I would suggest that you try to find another way, either used. It's a popular book, has been used very extensively, so you can either find it in used form or you just rent it. There are not going to be homework problems from the book. All of the homework problems will be ones I make. And everything is going to be open books for homework, midterms, final, the whole thing. It's going to be open books, open everything. I make the questions and the problems. And so you're not going to be able to find the same problems and copy any, of course, solutions. But, you know, I don't mind if you try to have your resources available. I mean, in true engineering environment, people don't tell you to go to your room and then turn off all of the electronics to solve the problem. Obviously, if you know how to find the right help, as long as it is accurate and it's not just copying somebody else's solution, I would say this is a valid way of solving a problem nowadays. That's how we do engineering. So with that, any other questions? I think the first 2 weeks you are going to see what I'm saying in practice. In earlier, I think you mentioned, let me see. So Chad, could you speak? Because I saw, let me see here, Chad. 1 second.
Oh, yes.
Yeah, go ahead.
Sorry, my internet's a little bad, so I may cut in and out.
Okay, all right. Now, I said that sometimes I will close them, some other times I will leave them open for up to 6 hours. But did I say that I will leave them open every time for 6 hours? I will check it out. Okay. So with the exercise, this particular one, since it's an example, I will turn it off, well, maybe in an hour or so. I will keep it on, maybe I will keep it on for another hour or so until people feel familiar enough to connect to it and get the answer. Okay? All right, well, thank you all. So we'll get together on Friday again, and I will be here for office hours today. If you have any questions, you can connect, and then you can answer any questions. You can answer your question during office hours. Thank you. Bye-bye.